Okay, all right. Hello, everyone. So, can you hear me now?
Yes,
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 sir.
yes, sir.
Okay,
Yes,
okay.
sir.
I think just please do let me know if at any point you are not able to hear me because there was some network issue from my end. Now I think somehow I have fixed it.
So now it's
Okay,
not clear,
so
sir.
let me share
And
my
again, sir.
screen.
And again with some disturbances.
Now can you hear me? Is it okay
No,
or
no, no.
Breaking,
same?
cracking like your sound.
Yeah.
So your sound is breaking in between actually.
Okay. Give me one minute. Let me fix it. Now is it fine? Somewhat.
Yes, sir. Now
Yes,
it's
sir.
clear.
Yes, sir.
Yeah. Okay. So let me share my screen and then we will discuss the things. Okay. Uh, of week 5 content. How many of you have started? Just you can raise your hand or give +1 or something so that I can get some idea.
Just one lecture, the first lecture.
Okay.
One lecture, sir.
Done, sir. Done.
Don't.
Week 5 done.
One lecture, sir.
Done, sir.
Okay.
Done, sir.
The two first lecture was some 45 minutes.
Sir,
Mm-hmm.
Prashant sir, do
Yes,
you
sir.
know our math instructor?
What happened?
Because sir, if you told him about our stats to structure that you guys are taking one solve with a session.
Mm-hmm.
I am also told them that if they take, so if you can told them the structure of this course because they are asking from me when I have told you. If you know them, please told them that please take a solve with a session.
So they are not taking solve with the session, is it?
No, 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 no. Instructor isn't taking.
Instructor is not taking.
No, no.
Actually, there won't be any solve this session. It will be embedded in the respective weeks, sir, always. Then before term,
Sir,
max 2. So.
Mm-hmm.
sir, at the end of the lecture, could you please share the previous year's paper for quiz one?
Okay, we'll see.
You
Okay,
can
can,
do.
can, can you see my screen now? Is it?
Yeah, yeah, sir.
Yeah.
Oh,
Yes,
Yes,
sir.
sir. Yes,
Yes,
sir.
okay.
sir.
Yeah, okay, just inform if there, if at any step you are facing any difficulty. Okay, so okay, so till week 3, you discussed about. I mean, we discussed about more on discrete random variable, right?
Yes.
Right.
I'm writing DRV for discrete random variable. We discussed about discrete random variable till week 3, correct? Now we started to study about continuous random variable in week 4, correct? So maybe you have seen the what is the PDF probability density function CDF, to calculate the probability. Let's say when x is if you're a continuous random variable, x is your continuous random variable, then x will lie between a and b and so on, something like this. Yes or no? These all things you have seen,
Yes, sir.
correct? Now in week 5, actually it should be week 5. I'm using the previous PDF, okay, old PDF. Okay. So in week 5, now we will see the function of continuous random variable. Okay. We'll see function of continuous random variable. Okay. So, okay, anyone, can you explain me what's the need of function of a continuous random variable? Why anyone would be interested for the function of a continuous random variable?
Uh, so like if want to calculate the area of a room, so
Hmm.
if x if some if we define x by random variable, then if you want to calculate the area, then this x is area is a function of x. So this way we can see.
Correct. Basically, we can say if we are talking about length of a square, let's say this is you are going to denote as x. Okay. Then area of that square will be
Length square or length is breadth.
right. Basically, I can
X
represent
square.
y as a x square, right?
Yes,
What is this x square? This is function of your random variable.
yes, yes.
Okay. So now the next thing is, but how to proceed to calculate the function of a continuous random variable. The main thing is, okay, let's say you are writing function in general, you are writing, let's say gx is the any function of my random variable. Okay. And okay, suppose you have x random variable. For this x variable, you have pdf is small fx, and let's say cdf is capital fx. Okay. So this is your cdf and this is your pdf. Okay. Now suppose you have a function of a continuous random variable. Okay. Which is I can write y equal to g of x. Okay. But how to proceed? So first of all, the very first step should be it's f. You can start with the cdf of your random variable. Okay. Then how will you write the cdf of a random variable? I can write probability that y less or equal to small y. That's the cdf. That's why we are defining the cdf, right?
Right.
Right. Then next step, what we can see at the y, what is the whatever the function you have, I can write g of x less than is equal to small y. Yes or no?
Yes.
So
Yes.
after that, what should be your next step? Actually, you have to see your capital random variable x such that this should be less than or equal to y as per the definition of the CDF. Okay. So basically you have to find the probability of the event, which is you can calculate by defining the using x. Okay. So what is the meaning? Let's say you got probability x square less than equal to y. Okay. Suppose y is defined as x square. Then what you have to do? The next step you have to define the x such that you have to convert this thing in terms of random variable y, in random variable of x, because you have the information about your random variable x. Are you getting my idea? See, if you have x square less than y, then next step what you can do? Can I write minus y less square root of minus square root of y less than x less than square root of y?
Yes.
Yes or no? Now what is
Sir, actually, you are not audible.
So your voice is your voice,
is it now? Can you hear me?
Yes.
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 Yes,
Yeah.
sir.
Okay, so are you getting my point? So here you have to calculate the probability when x is lying between minus of this quantity and plus of this quantity. Okay, are you getting some rough idea?
Yes.
Okay,
Yes.
so
Yes.
this is the general approach whenever you have to calculate the, you know, function. You have to find the CD distribution of function of a continuous random variable. You have to start with the CDF part. Okay. Okay. Let me start a very specific theorem. Then we will see some examples for that. So that for that theorem, it's called monotonic.
Sir, what is the meaning of monotonic, sir? Monotonically increasing, decreasing function they used to tell.
Okay. Anyone would you like to explain?
Without any
Monotonic.
effect.
Yes.
Without any effect.
Means
Monotonic units are those who have one behavior either increasing or decreasing.
Not both, right?
Strictly
Yeah.
increase, not strictly decreasing.
hmm.
Okay. So is it okay? I think who asked,
Yes, sir, I asked.
right?
Okay.
Did you get the idea?
Yeah.
So monotonic function basically it's like it's a function which no, it's either no never decreases or never increases or something like that. Basically, if I'm saying suppose you have what is the meaning of monotonic? Suppose I have
You
function
can
f of
say that like it's a unidirection.
unidirection. Yes, you can say.
Yeah.
So suppose I'm saying I have a function. If I'm saying if this function is if I'm writing monotonically increasing, okay, then if for all, let's say you have two values x1 less than x2, then in that case f of x1 will be less or equal to f of x2. Okay, this means actually your function either strictly increases or stays constant. Okay, are you getting? Same will happen for the monotonic decreasing case. So if function is fx is monotonically decreasing, then for this case your function f of x1 will be greater or equal to f of x2 in the okay. So if for all you can say x1 less than x2, so you will say your function is monotonically decreasing. So it means your function either strictly decreases or stay constant, right? Okay.
Yes.
Okay, now let's come to the theorem actually. So theorem says you have a theorem for that. What is the condition for that theorem actually? So suppose let me write, okay, suppose you have a random variable x which is a continuous random variable, okay, and for this continuous random variable we have pdf small fx. Okay, let g of x, okay, this g of x is the monotonic. Okay, if I'm writing monotonic means either it will be decreasing function or increasing function. Okay, for x belongs to support of x. Okay, this is something you have to keep in your mind. So your function g of x, this should be monotonic for the support of x. Okay, with derivative g dash x, I mean this function should be differentiable also, d of gx divided by dx. Then if this condition satisfies, then the pdf of y, that is gx, you can directly calculate as a fy of y equal to 1 upon, okay, how many of you are done this theorem? I mean those who have
Yes, I.
watched the lectures, is it okay? Did you get the idea behind this?
Yes, sir.
Okay,
From
No,
here
sir.
we can also goes to the affine theorem also.
correct, a fine theorem. So
Hmm.
this is the
Sir,
theorem. So in this theorem actually what is the case you have to keep in mind? So this function gx should be monotonic and differentiable. Okay, so that is the case actually. If these two conditions are satisfied, for not always, for the support of x, whatever the support of x is there, for that support of x, if your gx is monotonic, then you have to monotonic as well as differentiable, then you can directly calculate the pdf of y as a by using this formula. Okay, so let's see a very simple example. Okay, suppose I'm saying x follows exponential distribution with parameter lambda, then question is you have to calculate or find the pdf of x square. Okay, now what is this x square? This gx is the x square, function of x, right?
Yes.
Next thing
Yes.
is, if you see what is the pdf of exponential distribution, lambda into e raised power minus lambda x.
Minus
What is the
1.
support of x? X is,
Beta 10 equal to 0.
it will
Let
take
me
0 otherwise. Now you have to tell me whether for this support, this is the support of your random variable x, yes or no? Your function of random function of x is monotonic or not?
Yes.
You can
Yes.
simply draw, right? So for this support, when x is greater than 0, so this is, so your gx will look like, yes or no?
Yes.
Yes or no? This is your x square. So this is monotonic. This is increasing function when for x is greater than 0. I mean for this support basically. Still, is it okay to identify this monotonic or not?
Yes.
And this is differentiable also, right? You can differentiate the x square.
Yeah.
So far so good. Now we have to calculate all these things, right? So g dash, so this is g dash of g inverse y. Basically we have to interpret this all these
सर
notations. Okay,
फंक्शंस की इन इनवर्स निकालना थोड़ा सा रिवाइज करवा दीजिए, मैं भूल गया हूँ.
this is not inverse, this is differentiable, differentiation. Okay, okay, that I got your point. I
Yeah,
will come to that. Okay, I got
I
your point. Don't
forgot,
worry.
sir.
Okay. See, what is the function we have? We have y equal to x square,
Right.
and this y, if you see from here, what I can get, x equal to, I can write
Root
square root of y
root
or
y.
not?
Yes.
Yes or no? And if you
Yes.
see, what is this y? Can I write this is g of x basically?
Yes. Yes.
If I have g of x as y or y equal to g of x, can I write x equal to g inverse of y? Would you agree with me?
We can.
Right?
Yes.
So when this x means I'm talking about g inverse of y,
Root y.
this is equal to under root of y. So far so good.
So far so good.
Now next is, if you see what we have to calculate, basically we have to find the g dash of g inverse y. Okay, let's say if you will skip this, so what is this? G of x is 2 times of x, right?
G dex. Yes.
So g of x is 2 times of x, right?
Yes, sir. Differentiate.
Okay. No, okay. Oh, sorry. So g of x
G
is
dash
x square. X
x
square.
square.
Sorry. G of x is x square, right? Now g dash of x, can I write
2x.
2x? Are you getting? G dash
Yes.
means I have differentiate this function. So if you will differentiate n x raised power n, then it will be nx into n minus 1, right? And what is the x? At the place of x, what else I can write? Can you tell me?
Y.
G inverse y.
Of y.
This x. I can replace this
Root
x,
y.
Sir,
g inverse of y, this x. And if I'm talking about the values, so this x will be replaced by square root of y. Now, is this okay?
Yes, sir.
yes, sir.
Are
Yes.
you getting right? So if you see in the formula, we got this quantity, which is 2 root y. Yes or no?
Yes.
See, according to the theorem, what should be the PDF of y? Fy of y is nothing but 1 upon modulus of g dash g inverse of y into in the numerator part, it will be fx of g inverse of y, right? So you can see this quantity we already got it, right? Now, next thing is, what is the f of x? So if f of x is, if you see, you can calculate from here. F of x is lambda into e raised power minus lambda x, right? Then if I'm talking about fx of g inverse y, then what should I do in the right hand side?
Lambda
We
e
have
power
to
minus lambda
replace the x with the
Root y.
root y,
root y.
correct? Now you have this quantity and you have this quantity. You have to just substitute here. Okay. So what we will get? So fy of y will be 1 upon 2 root y, which is already positive, lambda into e raised power minus lambda square root of y. Uh, okay. That's all right. I think there is no term we can cancel out. And this is y will be greater than 0. We can cancel. Is this okay?
Yes.
Yes, sir.
So you can see how the theorem, I mean, how you can apply the theorem, right?
Yes, sir.
Let me do one more example, then I will ask you one question to all of you. Okay, that is okay for everyone.
Yes.
Okay, so let's me take, uh, okay, so let me take, suppose I'm defining PDF. This is not any standard distribution. Let's say this is 3x square, okay? And the support of x is 0 to 1. It will take value 0 otherwise, okay? Now my question is, you have to calculate the PDF of y equal to x square, okay? Now can you tell me whether this is monotonic and differentiable for the support of x or not? First of all, tell me this is monotonic or not.
Yes, yes, it is.
So
Yes.
3x square will look like something like this, graph
Yes.
of 3x square, right? So this is monotonic. Since, so suppose this is 1, right? This is 1, this is 0. So for this support of x, my function is monotonic or not? You can see this is either it will be constant or either it will be increasing, right? It can see, if your function is like this, you cannot say this is monotonic, right? Either like this or either like this. Yes or no?
Yes.
Yes, sir.
Yes.
So this is monotonic and differentiable. That this means I can apply my theorem. Okay. So this theorem is very important. You can keep in your mind because it's a very important. Okay. See this anyway. This is not going to come in your quiz one, but I'm just giving to somewhat idea. Okay. So what is the theorem? Fy of y will be 1 upon modulus of g dash of g inverse y into fx of g inverse y, right? Now what we have to calculate, we have y equal to 3x square, right? So what should I do? What should be my next step? First of all, let's try to calculate the value of x. Then what will be value of x? X square will be y by 3.
X root y by 3.
The case we have, okay. Oh, no. One mistake. I think no one reminder. So function is not 3x square. Function is x square only. Right? This should be x square.
It will be 9x raised to 4.
See, function is not. So from here, x will be square root of y, right?
Hmm.
So x is
Yes,
square
sir.
root of y. This means g inverse y is square root of y,
Yeah.
because y I can write as a g of x. So far so good.
Yeah.
Yes, sir.
Now you have g of x is as a x square. So I'm writing like this just for to, I mean, so that we can calculate easily. So this means if I will take the differentiate. If I will differentiate with respect to s, so g dash x will be 2 times of x. Now g dash x, that means g dash of g inverse y will be 2 times of, what is
Root
the
y.
value of
Root
root
y.
y?
Hmm.
This quantity we have, right? By
Right.
using this part, what is f of x? F of x is 3x square, right? Now fx of g inverse y will be 3
3y.
x
3y.
square. So that means 3y. Okay. Everyone is getting till now?
Yes, sir. Yes, sir.
So
Yes, sir.
you will
Yes.
apply the theorem. So fy of y will be 1 upon 2 root y into 3 times of y. Basically, this will get cancelled out. You will get 3 by 2 square root of y. What is the support of y? What should be support of y? See, support of x is 1. Sorry, 0 to 1.
Yes. So it will be 0 to 1.
0 to 1.
0 to 1 only.
Or
Yes.
Yes.
Because y is what? X square, right? So it will be again, if you will substitute value 0, you will get 0. You will get, if you will substitute 1, you will get 1, right? So support of y is 0 to 1, basically. Correct? Yes? No? All right. Any doubt?
Sir, can you just move up a bit if you don't mind?
Yes.
Sir, can you hear f of x g inverse y equal to 3y? Here value of x square is y.
Huh.
Here we are not differentiating it. F
No,
of
no,
x.
there is no need of differentiation. So if you read the, if you see the notation is just, so I'm just replacing the values, right? If I'm talking about in terms of x, this is 3x square. If I will talk about in terms of g inverse y, this will be, you have to substitute the values of x.
X, okay.
Got it?
Got it, sir.
Okay. Same case we did here. So you can see we had lambda f of x, we had lambda into e raised to power minus lambda x. If I will talk about in terms of y, g inverse y, then what is the value of x? X value of x, we got square root of y, right? Because y was x square. Correct?
Yes.
So we replace this x with square root of y. Understood?
Yes, sir.
Ah.
Okay, that means we are g inverse of y. For y.
Correct, correct.
G inverse of y. Well, first time we are differentiating it in numerator part. Same value we are
So
denominator part and
this dash means we have to do the differentiation one time.
one time. Okay.
Okay, this g inverse of y means, suppose you have y equal to g of x. Okay, so x I can write g in terms of g inverse of y. Okay,
Okay. Okay.
fine.
Okay. Yeah.
Now, so let me take one example, then we will another example actually. So you have to tell me. So you can see the theorem is useful when, okay, what which condition you have to check if for your theorem?
Horizontal
Monotonically
increasing or
differentiable.
decreasing.
Again differentiable.
Correct. Now let me see. Suppose I'm saying x follows uniform minus 3 comma 3. Okay. Then I'm saying you have to find the PDF of, let's say, modulus of x. Okay. Then tell me whether this function. Okay. First of all, if you see, if x follows uniform minus 3 comma 3, then small fx, I mean PDF will be 1 upon
By 6.
3.
by 6, right?
6.
So this is continuous uniform, right?
6.
So this square bracket means it follows
yes, b
continuous
minus
uniform
a.
B
distribution.
minus A, right?
1
Correct.
by b minus.
If
1
x
by B
follows
minus A.
uniform a comma b, then the PDF will be 1 upon b minus a. So 3 minus of minus 3, it will be 1 upon 6. What is
Yes.
the support of x? Minus 3 to 3. So far so good. It will
Correct.
take value 0 otherwise. Correct?
Yes,
Now,
sir.
what is your function? So function is y equal to modulus of x, right? You have to check. Okay, first of all, what will be the support of y? Tell me, what should be the support of y?
Sir, can you explain one more time f of x equal to 1 by 6? How 1 by 6?
Okay, so if I'm saying x follows uniform a comma b, so this square bracket means I'm talking about discrete, sorry, continuous uniform distribution. Okay, then PDF of continuous uniform distribution is 1 upon b minus a for when x is between a and b. Okay,
Okay.
where
Okay.
A is minus 3, B is 3. So it will be 1 upon 3 minus of minus 3. So 3 plus 3, it will be 1 upon 6.
Yeah, got it, sir.
Got
Thank
it?
you.
Now,
Sir,
tell me
excuse me,
what
sir.
will be the support of Y?
Sir,
Yes.
0 to 3.
sir,
0 to
in this uniform distribution that you just said, the B minus A,
Hmm.
this quite confuses because the x is following uniform distribution, so it should take any value between as minus 3, 3, minus 3, minus 2, minus 1, 0, and in
This is it's not, we are not talking about discrete uniform. It's a continuous uniform distribution. See, if I'm saying X follows discrete uniform, let's say I'm writing X follows, let's say discrete uniform with so it's just a, you have to keep in mind this bracket. Okay. So if I'm writing 1, 2, 3, 4, 5, 6. Okay. For example, let's write till 5 only. So this means what is the value of probability X will take value 1? It's a 1 by 5. So this is the, it can take any value between 1 from 1 to 5. So this is something I'm talking about discrete uniform. Okay. It's not about continuous inform. So continuous inform is minus 3 comma 3. We suppose I have a random variable X, so it's taking minus 3 to 3, and there is any value, let's say 1. Then it can take any value in between these two value. Okay. But in case of discrete, it's not possible. If this is the case 1, this is 2, this is 3, this is 4, this is 5, then your random variable cannot take any value between these two value interval 1 and 2, 2 and 3. Is the difference clear?
but this minus 3 to 3 and in discrete minus 3 to 3, the probability of taking any values in both should be kind of same now. But the uniform it have 1 minus.
Sorry.
If we take minus 3 to 3 in the discrete random variable and
Hmm?
minus 3 to 3 in uniform,
Hmm?
then probability of x taking any value in such ranges will be in the I mean, for the discrete it will be something else, and for continuous it will be something else.
Correct.
But why?
Then I think then I need to go to then week 4. It's
uh,
not about why. See, it's all about, so continuous is what? When your sample size is large, right? Then you are approximating the discrete. I mean, you are moving from discrete world to continuous world. Okay. So
hmm.
whenever your n is large, okay, you are moving from discrete to continuous, because if you see in case of discrete, what kind of CDF graph will look like? This is something. Your CDF graph will be something like this. Let's say this, something like this. Yes or no?
Yes, sir.
Why? This is because of jump, right?
Yeah.
And because of discrete, you are getting this jump, right? You can calculate the probability at a single point. Yes or no?
Yes, sir.
Now, tell me, if I'm saying n is, let's say, 10,000, what kind of graph you'll find? You'll
Uh,
find this kind of graph, right?
yes, sir.
There will not be jump, right? There will be no jump, because basically you will get your CDF curve like this.
Hmm. Yes, sir.
Or what you are doing? You are okay with the approximation, right? Let's say
Yeah.
I'm saying x follows binomial 5 comma, let's say half. If I will ask what is the probability x is less or equal to 3, you can easily add probability x equal to 0 till 3, and you can calculate exact value, right? If I
Yes,
will
sir.
ask x follows binomial 10,000 comma half, then I will ask, tell me the probability x is less or equal to 9,998. Let's say 99, some 68. How will you proceed? Are you going to add all this probability, or you are okay with the some continuous approximation?
Okay, with the
Continuous.
some continuous approximation.
Continuous
Hmm.
approximation, right? That's what continuous. So it's not like, see, if you are comparing the PMF, so actually in case of discrete random variable, we are talking about exact probability, right? You can calculate the exact probability, but in case of continuous, you cannot. It's not possible. Probability at a single point will be always 0. But in case of discrete, you can calculate, because in case of discrete, you can see your CDF graph will be something, there will be jump, right? But in case of continuous, it's not possible. Are you getting my point? So what is the happening there? So suppose I'm saying you have value A from B, right? A to, and I'm saying this is taking in uniformly any value from, let's say, A to B. This is, suppose this is K. Now can I write? Can I draw the graph like this or not?
Yeah. Yes, sir.
If I'm talking about, it can take uniformly any value between between A and B. Yes or no?
Yeah, yeah.
Yes.
If this is the case, can you tell me if if I want to calculate the value of this constant, what is the property of to find the PDF for a PDF? Area under the curve should be equal to 1.
Yes, sir.
What is the
Yes, sir.
area?
Area would be 1.
What is area for this square?
Integration.
AB into K.
Sorry?
The distance B minus A into K.
E minus A
B
into
minus
B
A
minus
into
into
K.
K.
Okay, then if you see, if you want to calculate the value of K, then I have to differentiate for X, and this
Was it equal to
differentiation will
1?
be equal to 1,
Correct.
yes.
Yes, yes, sir.
right? And we have to integrate from A to B.
Yes.
What is happening here? 1 into dx, A to B.
Yes, sir.
Then it will be basically, what is this? X, A to,
B.
I think some mistake is there. 1 second.
Sir, you have to. No, sir, no mistake is there, sir.
So it's correct till now.
It's correct, sir.
Into
You
B
can,
minus A whole square will come. Nothing else.
Whole square is there, right? So K will be 1 upon B minus A.
Actually, you have written area
Yes,
in the integral, sir.
yes,
B
yes,
minus
sir.
A into K dx.
Things right. B minus A into K into dx.
It should be K into dx equals to.
Yes, it should be K into dx. Not A
Correct.
to B.
Yeah, that's what.
Yeah, sir,
Sorry,
yes.
sorry. That's what. That's
You have
why.
written the
That's
actual
why
area.
I was worrying why it's coming out to square. Now it's clear, right? So K will be 1 upon B minus A, right? So this is the
Yes.
PDF of your informed distribution. Okay. So in case of continuous, we are okay with the some kind of approximation. Okay. So discrete, see, in case of discrete, it's very simple thing. If you draw a real line, you can count the things. Why in case of continuous, it's not possible. Okay.
Yes.
Yes, sir. Got it.
Suppose I'm saying there is a waiting time. You are the waiting time at a particular bus stand is let's talk about like this. Suppose bus arrival timing at a particular bus stand is 10 minutes to 15 minutes. That means what? That bus can come between that bus for that particular bus time can be anything, right? From 10 minutes to 15 minutes, right? It can be anything, right?
Yes, sir.
You cannot say 10, 12, 15 only. Something, right? Okay.
Yeah.
Now is this okay? I think you should then rewatch the previous lectures. Okay, then only then. Otherwise, we will left with the week 5. Okay, somewhat idea is okay or not?
Yes, sir. Yes, sir. Got it.
Okay.
Got it.
If you have any doubt, we can discuss at the end. Okay.
Yeah,
Now
yeah.
so let's come back to the question, our original question. So x follows uniform minus 3 comma 3, and we have to calculate the PDF of modulus of x. Okay. Now, and what was the PDF of this? It was 1 upon 6, and x will lie between minus 3 and 3. Tell me, if y is equal to modulus of x, then what will the support of y? Anyone?
0 to 3.
0 to 3.
0 to 3, right?
Yes.
Okay. Now, first of all, you have to tell me, can I apply the theorem, monotonic differentiable theorem, on this or not?
No,
No,
sir.
sir.
No.
Why?
Because it is uniform.
Because, sir, from 0 to 3, mod x would be different, right?
Sorry?
Monotonical increasing. It is not monotonical increasing.
It's not a monotonic function, because if you draw the mod of x, so this will look like something like this, right? The picture is, maybe we have to do the scaling properly, but graph is something like this, right?
Yes.
Okay. And this will be y. and this is your x. So you can see why this is not a monotonic, it's decreasing and increasing both, right?
Correct.
That means
Yes.
I
Yes.
cannot, this is not monotonic, so we can't use theorem. Yes or no?
Yes.
Sir, this is monotonic, na? This is a modulus of x, so it will just take the positive values. So this should be monotonic. Uh,
I have drawn the pictures of mod of x. Can you tell me by seeing this graph it's monotonic only?
no, no, it's not monotonic from the
Right?
graph.
Yeah, that's what we have to see about function, not values. Okay.
Yeah, yeah, yes, sir.
Now then I told you in the beginning of the session, if in general how we have to proceed, we have to proceed with the CDF of y. Yes or no?
Right.
Yes.
Yes, sir.
Right. Then what should I write actually? I mean, how should I proceed? CDF of y. Then f, capital Fy of y. Then I can write this probability y is less or equal to small y. Right. And what is the y? Capital Y is nothing but modulus of x. So far
Right.
so good. Any doubt?
Yes, sir.
I mean, doubt or is
No
it
doubt.
okay?
No, no, sir. No, sir.
Okay.
No.
No doubt, right? Okay. I think, yeah. So what should I
I have a
write
doubt
next?
here.
X.
Can
Yes.
we break this function in two parts, like, and make it zero and zero
X
to
will
three?
be between minus y and y.
Y
X.
will be minus, sorry, x will be minus y and y,
Yes.
right? So
Yes.
now, if you see, I can calculate this part, yes or no? Basically, this Fy of y, I can easily. So how will you find this values? This part. Probability minus y less or equal to x less or equal to y. This means I can do the integration from minus y to y for f of x with respect to x or not. Would you agree with me?
Yes.
Yes, sir.
Are you getting my point? So what we have to do, you can see your random variable capital X is lying between some two values, right? Those two values minus y of less than minus y less or equal to capital X less or equal to plus y. We have to calculate this probability, and we know probability. Let's say we have to calculate a less than x less than b. How we can calculate?
FB P of B minus P of A, basically. F of B minus
Yes, sir.
Fx B minus.
Probability of B minus probability of A.
Yes.
Yes, sir.
Actually, there is a problem with his voice,
Yeah,
sir.
yeah, with his network, yeah, is.
Can you hear me?
We,
Yes, sir.
yeah, we can
Yes,
hear
sir.
you.
Sir left.
Lots of topic in week 5 left still. Uniform distribution. है भाई मदब हंस क्यों रहे हो?
It's streaming, bro.
और तुम में से कोई हैकेथॉन में जा रहा है क्या? आईआईटी कानपुर में हो रहा है
No,
एमएल हैकेथॉन।
no.
आज लास्ट है ना डेडलाइन।
स्टेमनिफ में कोई है?
कौन सा हैकाथॉन चल रहा है? कौन सा हैकाथॉन है?
आईआईटी कानपुर टेक कृति एमएल हैकेथॉन।
तो फाउंडेशन वालों के लिए भी है?
अरे कोई भी ज्वाइन कर सकता है उसमें, मैं भी जा रहा हूँ, मुझे कुछ नहीं आता एमएल में।
मशीन लर्निंग के ऊपर है।
बताना यार लिंक।
हाँ जी,
लिंक बताना भाई।
वो टेक कृति सर्च करो, वेबसाइट में मिल जाएगा। मतलब उनका आईआईटी कानपुर का फेमस है। आज लास्ट डेट है रजिस्ट्रेशन का।
टेक कृति
आईआईटी कानपुर।
थैंक्स भाई।
भाई स्टेमनिफ कम्युनिटी में है कोई?
नहीं भाई।
Hello, can you hear me now?
Yes, sir.
Yes, sir. Welcome,
Yes,
sir.
I don't know what is the issue with the network. Now, is my voice clear? Can you hear me properly?
Yes, sir.
yes, sir.
Yeah. So, give me a minute. I will share my screen. What is the issue with my writing device now? Okay, so we saw. So that part is okay. We have to calculate the probability for a particular area. I mean, where x is lying between A and B,
Yes, sir.
right?
Your screen is not visible.
Yeah, I haven't shared till now. I will share my screen. Actually, I'm just connecting my writing device. I don't know what is the issue. It's not. I'm not able to connect.
Some technical glitches, I think, sir. Who is in the chat box saying something? Sir, are you there?
Yes. I'm here. I'm just trying to connect the writing device. Okay, so can you see my screen?
No, sir.
No, sir.
Is it okay now?
Yeah, visible.
Okay.
Now
So
Yes.
this is something we can calculate, right? So first of all, sometime we have to see whether for all the possible values of y, whether this case is possible or not. So you can see y will take any value from between 0 and 3. Okay, let's say 3 is somewhat here. Okay, so you can see if you will substitute any value of y, let's say you are substituting minus, let's say you are substituting 2. Okay, then okay, let me write like this. So what will be your x? It will be minus 2 to 2. Yes or no? Which is possible? Yes or no?
Yes.
Yeah.
That means I can do for any values of y. You can cross check, right? There is nothing we have to put any condition. So I can simply integrate, and if you will integrate minus y to y, and what is the f of x? This is 1 upon 6, correct? So it will be
Right.
1 upon 6, and it will be, we have to do minus y to y, 1 into dx. Basically, it will be 1 upon 6 x minus y to y, and we have to just substitute the values. I'm assuming you are okay how to do this derivation, right?
Yes.
So basically, it will be 2y by 6, that is y by 3. But this is the CDF. We have to calculate the PDF. How I can find the PDF of y?
Differentiate
We
PDF.
have to differentiate this CDF, right?
Yes, sir.
Yes, sir.
So if you will differentiate y by 3 with respect to y, what you will get? You will get 1 by
3.
And what is the support of y? 0 to 3. So can you guess the distribution fy of y? Anyone? What will be the distribution of y?
Uniform 0 to 3.
Uniform.
It will be uniform
0 to 3.
0 to 3. One more thing you can do from here, right? So there is another approach from here onwards. So we had fy of y as probability minus y less or equal to x less or equal to y. And we know probability a less than x less than b, I can write as a f of b minus f of a, right? So can I write from here fx of y minus fx of minus y?
By 6. Oh, yeah.
Yes.
Okay.
Now, what is the CDF of in case of uniform distribution? If x follows uniform a comma b, then what is the CDF fx of small x? This is x minus a divided by
Minus
b
A.
minus a. This is direct CDF formula. So here I can do y minus a. What is the a? A means
Minus
A
5.
minus Y.
x follows minus
Minus
3 comma 3. So it will be a y minus 3 minus 3, and denominator will be 6 minus, it will be minus y minus of minus 3 divided by 6. So far so good. So you can see what it will be y plus 3 divided by 6 minus of minus y plus 3 divided by 6. And if you will solve this, basically it will be y plus 3 plus y minus 3 divided by 6. So 3 will get cancelled out. So 2y by 6, which is y by 3, which is same as this PDF. Okay, I mean which
Yes.
same as when we integrated. Okay, so both approach is okay. That's not a problem at all. Is
Can
this
you
okay?
approach a bit? Yeah.
Sir, we are done a different approach in the example. In the earlier, we have done the doing the differentiation, and then this way. So we are doing the
Yeah, so I'm telling you the two approach. Okay, so you can directly apply the CDF formula if you had any standard distribution and you know, or else if you are okay with the different integration, you can go with this. So either way, you will get the same answer.
So in the CDF part, the equality sign doesn't matter, like x is
It's a
less than
continuous,
equal.
right? In case of
Yes.
continuous distribution, equality sign doesn't matter because probability at a single point will always be 0.
Okay.
Is this
so
okay?
So it is
Yes,
not
sir.
monotonically increasing, so we can do the other way.
Sorry?
It is not monotonically increasing or decreasing, no, sir.
Huh?
So we can apply the other formula.
No, there is no formula. So if you see here, we are not applying the theorem. We are
Okay.
doing in general way.
Yes. Yes.
Okay.
Okay.
If you have theorem, I mean, if your conditions of the theorem is fulfilled, then you can apply the theorem. And if functions should be monotonic and differentiable, then you can apply the theorem directly. Otherwise, you have to start with the CDF of y, and then you have to proceed like this. Okay.
Oh, okay.
Okay. Let me take
Sir,
one example. Yes.
sir, what if we go half by half? Half it is monotonic, half is monotonic. So first we go with half, then
Then do I would request you do a small research on this.
Sir, in this one,
Hmm.
so 2y by 6 is the fine probably, right?
No, no, this is the CDF. This is
Ah,
not answer. Ah. So I'm just explaining here. This CDF y by 3 is same as the above one y by 3. Are you getting the difference? What I'm trying to explain. The above one I used this above CDF fy of y. This I calculated with the integration part, right?
right,
Means
understood.
from for this I applied the let me make it as a star. For this star I started with the CD integration formula, and we got y by 3. Okay, but to calculate the
Yes.
PDF, what we have to do, we have to do the differentiation. But what I'm saying, rather than doing the integration, you can also start, I mean, you can apply the CDF formula directly. And in that case, again, you will get the y by 3, which is the same as the CDF of when you did integration.
In
Clear?
the F4 uh, in the aforementioned case, first we calculate PDF, then we differentiate that, then so we get
PDF. First,
the
you have to calculate the CDF, not PDF.
CDF.
PDF you have
Then
to
we
find, right? So without
then
proceeding with CDF, you cannot find PDF.
okay.
Is this
Sir,
clear?
sir,
Yes, sir.
in this case, is coming y by 3 is coming CDF. Now
Hmm.
we'll do for PDF. We'll differentiate it, and
Correct.
the answer will come 1/3.
Correct.
Okay.
Correct.
Okay.
Sir, one silly question.
Hmm.
This function is not a monotonic. Okay,
Hmm.
by mistake, anyone applied this. Can we get the same result? Process is
You
wrong.
can try. You can try. Actually, I didn't try.
Okay, well,
Because suppose I'm saying once I will see it's not monotonic, I'm not going to proceed with the theorem. Okay, you can try and you can see what is the difference coming out to be. Okay.
okay, sir, I will try.
So, sir, in this one, we are basically keeping the lower limit as -3 always in this, basically, in this method, the second one, right? Approach 2.
Huh? Huh?
So, the lower limit will always be -2 for me, -3 for me, right? And the upper limit will be respectively y and -y. That is what you have done, right, sir, here? Fxy minus fx of minus y when you have done.
Huh?
So, here you have, since you have taken, right, y minus of -3 by 6 minus y minus of -3 by 6 minus of y minus -3 by 6. So in
Hmm.
this one, my lower limit is always -3, right? And my upper limit will be y or minus y for both the cases, right? Which generally follows the formula for CDF, where fx of x is less
No, no,
than.
I'm not getting your doubt. What is your doubt?
No, in this one, sir, what I'm asking is that
Hmm.
since you have done right, like for fxy minus fx minus y, you have done right, y minus of
Hmm.
-3 by 6 minus of minus these two terms basically.
Hmm.
So
From
here
where it
we
is coming?
no that I can understand. Yeah, this -3 basically is the lower limit, right?
Yeah, that's what this is A, right?
Okay.
See, some basic formula should be in your mind. So if you see x follows uniform, continuous uniform A comma B, then CDF is x minus A divided by B minus A. Okay. But here, what is A? A is -3 and B is 3. That's all. Okay.
Yeah, sure.
Clear?
Yeah.
Okay. Okay, then let me move to the next topic. I wanted to discuss one more example, but let it be. If you have doubt, we can discuss in the next session because we have to cover the concept. Okay. So we have seen the expectation of your random variable. Okay, expectation and variance. Okay. So one general suggestion, whenever you are doing in general approach and you are at this step, just cross check for the whether for the support of y whether this condition is fulfilled always or not, because in some cases you will not find this case always. Then you have to separate the ranges. Okay, means you have to separate the ranges, means you have to separate the, basically I can say, the support of the case. Are you getting my point, or should I explain you more?
Sir, explain more.
Yes, sir.
I think it would be great if you have. Okay, let it be. Suppose I'm saying x follows uniform minus 3 comma 1. Okay, and you have to calculate the PDF of x square. Tell me whether this is monotonic or not.
Monotonic.
No, not.
X square.
It's monotonic.
I
See,
think
monotonic in terms of what? Monotonic for the support of x, right?
So it's not monotonic, sir. It is range is -1 to 0, -3 to 1.
Minus 3 to 1, right?
Not
Suppose this is
negative
minus
value.
3. This is, suppose this is 1. Then for this support, what will your graph look like? So my graph will be something like this, right?
It will
If it was 0, then it is
decrease
monotonic.
and then again.
But it is 1.
Right. But if support is 0 greater than 0 onwards, then it's a
Then it's
monotonic, right?
monotonic. Correct.
It's not a monotonic here.
Yes.
So I cannot apply the theorem directly, right? So, okay, first of all, what is the PDF of here? 1 upon?
1
by
4.
1 upon 4, because 1 upon b minus a.
Yes.
Now, what will be the support of y?
1, 0 to 9.
0 to 9. Okay, so maximum values y can take, this is suppose g of x or y, it will take 9. Okay, suppose this is 9. Okay, now my question is, we have to proceed? We have to start with f y of y, right? So this will be probability y less or equal to y. And what is the y? Y is nothing but x square less or equal to y. So far so good.
Yes, sir.
Now here you have to think, because if I'm writing probability x square is x square is less or equal to y. If I'm writing, first of all, I can write minus square root of y less than x less than square root of y.
Correct.
Correct. But in the previous example, I did the integration, but here I cannot, because we have to check whether this condition is fulfilled for all values of the y or not. Suppose when y can take value from 0 to 9. If you see if y take 0 to 1, is it possible this case?
No.
Is it possible or not? My question is it possible or not? This condition will fulfill if y is 0 to 1 or not? Yes, right?
Yes, sir.
0 to yes.
Right? If you
Yes.
if you are taking 1, it will be -1 to 1. This is possible. If you are taking 0.5, it will be minus 0.5 to 0.5, right? It's possible, right?
Right.
Yes, sir. Yes, sir.
Now, just be focused. If y is proceeding for y1 to 9, is it true? This case will always be true.
No, sir.
If you're taking y as a, let's say 4, then it will be -2 less than x less than 2, right?
Yes.
Yes or no? This is not possible,
Yes, sir.
because maximum limit of x is 1 only, correct?
Yes, sir.
In this case, it will be minus square root of y less than x less than
1.
1. So that means this is one case, this is second case. You have to solve for this, you have to solve for this, and you have to add these two. I mean, not add, you have to consider these two cases. Okay.
Sir, why you are writing minus y less than equal to x less than 1? Because when you are taking 1, it should be -1.
You are taking 1. Suppose I am taking 3.
Then
Then
3 in the first case, 0 to 1 range. 3 is out of range.
Why? If you are taking y as a 1, right, then you will get -1 to 1. How it's out of range? X can take any value -3 to 1, right? If you're saying 1 and I'm saying this means you have to calculate the probability -1 to 1. It's possible, right?
Hmm.
Why
But
in the second?
sir, you can't include sir -3 na, because it will not fulfill the logic, because if you put -3, it will give you imaginary roots.
See, I'm not including the -3. That's why I'm taking y as a 0 to 1 only. If you will take y 1 to 19, in that case your y will be, you can take a value 3.
Yeah.
Right? But here, if you are taking y as a 3, then max lower limit -3 minus of square root 3 is possible.
Yes.
Let's say you are,
3 is not.
but upper limit is possible or not?
Upper limit.
Let's take 4. See, if y belongs 1 to 9, y can take value 4 or not? In this case, y, if I'm taking y as a, okay, y can take 4 or not?
Yeah, no, I take 4.
Y take 4. If y is taking 4, if you will substitute values here, then this means I'm talking about -2 less than x2.
It's
Is this
possible.
possible? Is this possible?
Yes, possible.
How?
Because x in the range of -2 to 2.
What is the limit of x?
X
What is the
limit.
limit? What is the limit of x?
-2 to 1.
Minus
-3
3
to 1.
to 1 only, right?
Out of range.
Correct. So that's why I kept maximum limit is 1. So whatever values of y from 1 to 9, it cannot take maximum limit more than 1. Is it okay? Okay. Now what you have to do basically, now what I can do for this part, I have to do the integration from minus square root of y fx dx, right? Minus square root of y, and it was 1 upon 4 dx. Okay. If I will solve, so it will be square root of y plus square root of y, 2 root square root of y. Basically, I will get 2 square root of y divided by 4. I will get square root of y divided by 2. Right? This is the CDF in case 1. And case 2, I have to do the integration from minus square root y to 1.
1.
It will be 1 upon 4 dx. So it will be 1 plus square root of y divided by 4. Right? If I'm not wrong. Now, if you have to calculate the PDF, right? So PDF you have to differentiate the CDF, right? So you have to differentiate for both cases. So for case 1 and for case 2. So if you will differentiate for case 1, okay, let me write. So fy of y will be what? If you will differentiate for case 1, it will be what will be the differentiation of a square root of y?
1 by 2 root
1 by 2 root y when y is 0 to 1. And what will be the differentiation for this part? Basically, I can write 1 upon 4 plus square root of y by 4. So if you will differentiate, so this part 1 by 4 will be 0. So it will be 1 by 4 into 1 upon 2 root y. When y is 1 to 9. Is this clear now?
Yes, sir.
So whenever you are not able to apply the theorem directly, just see you have to approach in general, and as well as whenever you are coming at any condition, just check whether this is possible for all the support or not. Okay. Okay. Rough idea is okay or not? Are you getting the rough idea? Whatever the things we have discussed. Okay.
Yes, sir.
The next thing is expectation and variance about these things. Okay. So why we are discussing expectation and variance of a continuous random variable? Because if you see, anyway, we are talking about. Yes.
Can you scroll a little bit up for 1 second? Okay, sir. Thank you, sir. Okay, sir.
So how we are defining expectation of x? This is
E of x.
Integration.
X into f of x.
f of fx dx, right?
F of x dx.
We have to differentiate with, we have to integrate for the support of x.
Minus infinity to infinity, na? Limit should be?
See, whether I'm writing x here, that this means whatever the support of x is, whether minus infinity,
Yes,
infinity, a to b, doesn't matter, okay? So I can write here support of x. Okay. Then if I'm talking about expectation of a function of a random variable, then it will be g of x fx of dx. Yes or no?
Yes.
Now, if you see the variance, how you can calculate variance of a random variable, it is defined as expectation of x
Expectation of
square
x square
minus expectation of x whole square. So
square.
expectation of x you can calculate as a integration of x fx
X,
dx. Right?
yeah,
This
Yes.
expectation of x square, this is a
x
function.
square
So x
integral
Correct.
x
square
square f of
fx,
x dx.
right? Is this clear?
Hmm.
Okay. So I'm
Yeah.
not taking any example for this. So let me take some another concept, which will take some minutes. Okay. I think this is okay, right? You can do the basic integration. Yes or no? Okay.
Yes, sir.
Just try some examples. If you are getting any difficulty at any point, do let us know. Okay. We will answer for that. Now, what the next thing I'm going to discuss is important actually. Maybe how many of you covered all the lectures? Okay, one people, only Divya. Okay, Divya, Deepak, and one more person.
Seven.
Okay. So next concept, what I'm going to discuss is joint distribution of discrete and continuous random variable. Okay, so do not think this is some uh, this is something which is not going to apply in real world. This is very applicable part. This joint distribution of discrete and continuous random. You can find, you will find whenever you are, when you will move in machine learning courses, this concept is going to play a very important role there. Okay, actually whatever the concept we are learning in stats 2 and we will learn in upcoming weeks, those are all are important. So do not learn with respect to just to give the attempt the G and get full marks and all. If you are getting full marks, if you are doing on your own, then it's very good. Try to learn the concept as well. Just, I mean, at least some, see, at the time, by the time, after some time, you will forget the thing, but some concept, some overall rough idea should be in your mind, so that whenever you will learn something new, you should be able to relate. So that's why we have learned something in stats 1, let's say base theorem. Those base theorem is going to applicable here, and including these two topics, you can see the base theorem is very going to applicable for Bayesian estimation problem. And those Bayesian estimation problem is again helpful for machine learning techniques. Okay. Okay, let it be that we will discuss later. So suppose we have to calculate the joint distribution of discrete and continuous random variable. Okay. Let me say, so suppose let me define some notice. So suppose I'm saying X, I have a discrete random variable, okay, and with range. So generally we are writing tx, right? And let's say if this is the discrete, this there will be pmf. So pmf, let's say px of it. Okay, is this notation clear?
Yes, sir.
Okay, so suppose what is the condition? So suppose I'm saying for each value of x, okay, for each x from the range of x, what are the values of x? Suppose we have a continuous random variable. Okay, and so how this is defined? Continuous random variable. Let's say I'm writing y(x). So this y(x) means I'm saying y given x equal to x. So this means I'm saying the same as y given x equal to x. Okay. So case is you have one discrete random variable. This is taking some value, let's say 1, 2, and 3. For each values of x, let's say x is taking value 1, y axis taking value 2 and axis value taking value 3. For each value of x, you have a one continuous random variable. I mean one conditional, basically you can say conditional random variable. Okay. Now the case is, if question is, if you have to, first of all, let's say you have to calculate the marginal distribution of y, then how will you proceed? Anyone, any idea? Okay, let me give you the some rough idea of law of total probability. Okay, what is the law of total probability? Suppose this is the total sample space, and this is B1, and this is B2, two events, and there is another event A is occurring. Okay, if I will ask what is the probability of A, how will you proceed? Probability of A and B1 plus probability of A intersection B2, yes or no?
Yes.
And this A intersection B1, how you can write probability of B1? What is the probability of B1 into what is the probability of occurring A in the B1 given that B1? Yes or no?
Yes.
Plus
Yes.
probability of B2 into probability of A given B2. Is this formula okay?
Right.
Yes.
Right. Now, if I want to calculate the marginal distribution of y, so suppose you can consider b1, b2 as a discrete values of my random variable is taking, right? Let's say this is x1 and some values of x2, right? And this is the y. Now, if by using this in formula, can I say fy of y is nothing but I have to do the summation for the range of x, okay, when px of x, discrete of x, into conditional density of when x is, I mean, y given x equal to x. Yes or no? This is basically what is happening here. Let's say x is taking value x2, only two values, x1 and x2. Then how I'm doing? So this means px of x1, okay, into fy given x equal to x1 y plus px of x2 into fy given x equal to x2 y. You can relate. So this is b1 a given b1 conditional plus second value conditional. Is this okay?
Okay.
Yes. Are you able to relate the formula? And anyway, so we have to calculate the marginal distribution of y. So the x is the discrete. We have to do the summation throughout the range of x. Yes or no? Correct. So you can think like this. So this is suppose this is x1. So this x can take any value. Suppose if you have discrete random value, suppose x is taking three values. Let's say x1, x2, and x3. And there is something condition. This is y, for example. Some condition we don't know. We will take some example, but as of now, let's try to understand the formula. If I'm asking what is the PDF of y, what is the distribution of y, margin distribution of y, how will you proceed? So you will be interested. What is the probability of y given that x1, right? Probability of y x2, probability of y intersection of x3, right? And how you can calculate this part? You can say probability when x is taking x1 into when x is x1 y.
Why?
Yes or no?
Yes.
Basically, x is taking value x1. Give me a minute. Okay, so this means x is taking value x1. Given that x is taking x is already taken value x1, what is the probability of y, right? So you can relate like this. So x is already, you can see, if you will see this part, x has taken already x1. What is the probability that of occurring y? So x is in this whole x, this is y, right? Are you able to relate? Same for x3. Is it okay? Yes, no, any doubt? Is it fine?
Yes.
Okay.
Yes, sir.
Now, so question is to calculate the, now if you see the conditional probability. Okay, what is the Bayes theorem? For that part, if we have B1, B2, A, we calculated probability of A as probability of B1 into probability of
A into
A given B1
given B.
plus probability of B2 into probability of A given B2. So far so good. What is the Bayes theorem? Bayes theorem says, I'm saying probability that A has already occurred. What is the probability that it will occur for B1, right?
Right.
So this will be probability B1 intersection A divided by probability of A.
Yes.
Yes or no? So what is numerator part? Numerator part, if you see B1 intersection A, sorry, then I can write probability of B1 into probability of A given B1. Yes or no?
Yeah, we can.
All right. Numerator, sorry, denominator part is this part. So I can write summation of I, probability of Bi into probability of A given Bi. Are you getting? See, I is nothing but 1 to 2. I just wrote in general this part.
Yes.
This is the probability of A, right? This is probability of A. You can calculate. Are you getting my point here? Is this Bayes theorem is clear or Bayes formula is clear or not?
Yes, clear.
Right? If this is okay, can you tell me? So we saw the marginal P distribution of Y as a summation of X over the summation X over the range of X. So this is P X of X into F Y given X equal to X of Y, right? Yes or no? If I'm asking what is the probability that X equal to X given that Y equal to Y, then what will be the numerator part? First of all, probability that X equal to X and Y equal to Y divide by denominator part. I can write Fy of Y.
Yes.
Yes or no?
Yes.
Yes or no?
Yes.
So if you see the numerator part, what else I can write for the numerator part? Just think like this: x1, x2, y.
Probability of x into probability of y given that
x
x
and
is equal to x.
Correct. So can I write px of x into conditional of this part?
Yes.
Yes or no? Do you agree with me? Yes? No? Is this okay? See this margin, sorry, this intersection part. If I'm right, if you see this intersection part, how you can write marginal into conditional. That's all. Right?
Right.
Okay. The same thing here. This if you are talking about intersection part, I can write as a marginal into conditional.
Okay.
Okay.
Got it.
Okay.
Now, okay, let me take one very simple example. Maybe that will give you more clear picture. Okay. Let me take what else I can take. Yeah, let me take something like this. Okay. Suppose I'm saying X follows uniform minus 1 to 1. So you can see this is discrete, right? Yes or no?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Now, so this is the case. I'm saying we have one more information. Let y given x equal to minus 1 will follow uniform. Let me take as minus 2 to 2. So this is continuous uniform, right? And
Yes, sir.
this will be exponential pi. Okay, is the question clear? So question says x is this is x is discrete and conditional distribution is continuous, right? You can say we have continuous conditional part, right? Yes or no? So my question is, if you have to calculate the marginal distribution of y, okay, then we have seen Fy of y is what? We have to do the summation over the range of x, right? Px of x, marginal distribution of x, and conditional density when x is given to you. Is this okay? Right,
Okay.
this is the formula,
Right.
right? So question is, how will you proceed? So what is, so this means, see, if you see how many values x is taking, two values, right? -1 and 1, right? So this means we are interested in probability x is taking value -1 into f y given x equal to -1 of y plus probability x is taking value 1 into f y given x equal to 1 of y. Is this okay? Is this clear? The separation part?
Yes, sir. Yes, sir.
Right. So here you can see we have to do the summation for the range of x. So what is the range of x? X is taking uniform -1 to 1. X is taking only two values, right? -1 and 1. Correct?
Right.
Summation of both
Summation.
values.
Summation of. Now what is the probability of x will take -1?
Half.
Half.
What is the probability for this? What is the distribution PDF for this? So this is
1/6.
uniform, right?
1/4.
Yes or no?
1/4. 1/4.
1/4 plus 1/2 into what is this?
Exponential.
Exponential.
Lambda e power minus lambda x.
Correct. But yeah, so for now I can write, right? 5 e raised to power minus 5 y. Okay. But one more thing, is it true for all range, all the values of this case or not? We have to think a bit. So this is not overall. So this will be changes for the okay, different values of y. Why? Because if you draw the graph, right? So why I'm saying like this. So again, I would suggest to try to see the changes. Okay. So if you see, initially it was -2 to 2 conditional part, right?
Right.
And one conditional part was 5. Suppose this is 5. This is exponential graph, right? Suppose this is 1. So this is something like this. Yes or no? Yes or no?
Correct.
Correct. Now you have to think for all the values of y here, whether it's true or not. So tell me, I'm writing something, you will give me the answer. Just try to think. If I'm saying y is less than -2, what will be the values? F of y of y. What should be the values?
0.
0.
0,
No.
right? Why I'm writing like this? Because it will change. So it's not true for all the support for overall the support of y. If I'm writing -2 to 0 till here, -2 to 0, what should I write? -2 to 0. Only this part?
Yes. Half
Yes.
into.
Yes, sir.
Because this will happen when y is greater than 0, right?
Zero.
1/2 into 1/4, right? If now that is the answer. If I'm writing y is between 0 and 2, then this will be true.
Exponential.
Yes or no? Would you agree with me?
Yes.
So you can substitute any values between 0 and 2, you can find this here. If I'm saying y is greater or equal to 2, then
1.
One.
no. It's not 1. This is not a CDF part. PDF.
Uniform, so it is 0.
Just think, if y is greater or equal to 2, which part you can calculate? You will include
1 minus.
okay,
1
this
minus.
part or not? Because in this case, y is greater or equal to 0, right? Yes or no?
Summation. We'll do summation.
No. So I'm saying which part you will include for y
Oh,
greater
yes,
equal to
yes.
2,
This one we include. Last one.
right? Last one, right? So, okay, I think as per your silence, I can feel you are not getting this part. Yes or no?
No, sir.
Ah.
Please explain, sir. Not getting.
Okay. No worries. So I will take some other example so that that is something when you will watch some other lectures. I mean, some more lectures, and you will try to solve. Then it will be clear. So my question is, so okay, let me try to explain again. If you are not getting, let it be for now. Okay. So Fy of y, you got this part, right? Correct.
Right.
But my question is whether this part is true for all over the values of y or not, right? That is something you have to think a bit. So if you will draw the graph, is it true for whatever the values of y will be there? No, right? It is not always true. Yes or no? So for different values of y, you will get different form of PDF. Yes or no?
Yes,
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 sir.
Right?
different video.
Because if I will take y less than -2, that means, see, in that case you cannot write PDF of y is this one. Yes or no? If
Right.
you will take
Yes.
-2 to 0 part, then in that case, what will be the PDF of y? That
Uniform.
Half and half.
uniform one, right? This left part, correct? So when y, see, you can think like this: when y is -2 to 0, then only this part is possible, right? This part is not, because in that case, this case is possible when y is greater or equal to 0 only, correct?
Right.
If you see y between 0 and 2, then in that case, this whole part is possible.
True.
Yes or no?
Yes.
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 And if y is greater or equal to 2, then only this
Only
part is possible, right?
correct. True.
Because if you see, uniform is going to end here, right? Only the exponential curve will continue from here onwards. Yes or no?
It will keep going.
Yes,
Keep
yes.
going on. Yes or no?
Yes. Yes.
So for y
Sir,
greater or equal to 2, only this part is possible. Okay. Just
sir,
see,
but
if you are not getting, don't worry. Just whenever you will try to solve more questions, it will be clear to you. That's not a problem. Okay. Yeah, you are asking something. Let me take another example. Maybe that will give you idea. Yes, go ahead.
sir, I was saying if y is greater than 2, it should be 1 minus probability of less than 2, right?
That is something. If I will ask to calculate probability, that's not a problem here. We are finding the PDF. We are not finding the area under the particular thing. Okay. So here, this is the for see that I'm not saying what is the probability between what is the probability of y greater or equal to 2. That is the different thing. I'm saying when y is greater or equal to, if I will ask probability y is greater or equal to 2, then you will see you can do this. This is not a case. I'm saying for this support, when y is greater or equal to 2, fy of y will be this part. Okay. These two things are different thing. Okay.
Okay, sir.
Now let me take another example.
Excuse me, sir.
Huh?
Yes, sir. I had just one little doubt.
Hmm.
So at the point of 0,
Hmm.
we have transition point, right?
Yes.
Before 0, we have some value. And after 0, we are adding exponential value
Correct.
in our
Correct.
uniform distribution. So what will be the distribution at the point 0? Will it be
So
0 or
at a exact you cannot calculate, right?
the whole thing
This
will be continuous then?
Yeah, this is the continuous, right? So at
Okay.
the exact point,
Mm-hmm.
you cannot define any area.
Yeah.
Are you getting my point?
Yes, sir.
That will be
That's
there.
why I'm clarifying with you. Yeah.
Hmm.
So we are not able to calculate at
No,
exact point 0
no,
or
no.
between -2 to 0 also.
Correct. -2 to 0 we have.
We can.
We can. Because see, we
Okay.
are interested in this whole region, right?
Mm-hmm.
So -2 to 0, the only possibility is uniform case, right?
Okay.
That's all.
So in this we can we calculate exact at particular point?
No, even you
No.
can't. See, if you will
Okay.
say, suppose here
Mm-hmm.
I'm saying what is the probability that y will take -1? It's a
Hmm.
0.
0. Yeah. Okay, sir.
It's a
Yeah,
Okay.
yeah. Okay, sir, got it.
Okay.
Yeah, thank you, sir.
Okay.
So today,
So suppose
until what topics will be covering, sir?
so this is the last topic. I'm just taking example. I will take one more example, then I will close it. Okay. Because I think you have math session also, right?
Yes, sir.
Yeah. So I will just
Today's
close
math
it.
session is
No, sir.
cancelled.
No, sir.
Math session
No,
is
sir.
cancelled, sir.
Cancelled.
Okay, then great.
Rescheduled tomorrow.
Okay, then great. I will take some more examples then. Okay. Okay, so suppose I'm saying x follows uniform 0, 1, and 2. Okay, and then y given x equal to 0. That's information is given. It's a normal mean 5, and let's say 0.4. So 0.4 is the standard deviation. Okay, so this is standard deviation. So let me take square. Okay, because usually we are writing as a we are taking variance. Okay, so if I will take y given x equal to 1, so let's say this is normal 6 comma 0.5 square, and y given x equal to 2, this is normal distribution with 7 comma 0.6 square. So the key thing is we have to calculate the fy of y. Okay, that is marginal distribution of y. So before this, what we have to do? So that means we have to do the summation over the range of x, px of x into fy given x equal to x of y. Yes or no? And we know what is the px of x for each values of x. It's a 1 by 3.
1 by 3.
1 by 3 always, right? So
Yes.
let it be for now. Let's try to focus here. So what will the fy given x equal to 0?
It will be the normal distribution.
Normal distribution. What is the PDF? I'm asking. So 1 upon. So in general, 1 upon under root 2 pi sigma, right? So sigma is 0.4. Okay. And e raised power minus 1 by 2 sigma square, 0.4 square into
minus
x
mu
minus mu square, right? Y minus 5 square.
divided
Yes
by
or no?
my standard deviation ka the whole square.
Correct? Yes or no? Same for y given x equal to 1 for y, just a change of mean and variances. So instead of 0.5, 0.4, it will be 0.5, right? Are you getting whatever I'm writing here? This is the PDF of
Right.
normal distribution.
Normal distribution.
Then 1 by, it will be 2, 1 upon under root 2 pi, 0.6. Yes, 0.6. E raised power minus 1 by 2, 0.6 square, y minus 7 square. Correct? So what else we have to do for fy of y? So it will be 1 upon 3, right? 1 upon 3 will be common, I think, correct? And addition
Yes.
of all these things, right? Everyone is getting whatever I'm writing here?
Yes.
All these values. Okay, I'm not writing the values here. Okay. So can you tell me now, is there any need of separation or no? You can draw the graph actually and then think. So for first graph is normal 5 comma, let's say mean is, this is for 5, right? Then another is 6, right? So that will be somewhat here, suppose. So let's say curve is something, peak will be at 6. Okay, we need to draw carefully. Okay, for 7, peak is at 7. Okay, so this means, let's say peak is at 7. So this is the case. So peak is at 7. This is 6. Okay, we have to just adjust. Can you tell me, is there any something we need to do the separation part? Can you think? Yes, no? No, right? Or yes?
No.
No, right? So this is just a mixture of normal distribution, correct? Now let me take one more, some real life example. Okay, let's say, let me write that example. Okay, I think that is from lecture itself. Okay. So suppose if I'm recall correctly, 60% of adults in the age group of some age group were there. I think let me take anything. Let's say 40 to 45 age group. Okay. Uh, let's say in any country. Okay, are male, and then let's say 40% are female. Okay. So suppose the height, okay, the height can be anything, let's say in centimeter itself, okay, of, okay, heights of, adult male. So you have to pick the things from this story. Okay. In that age group, is, let's say I'm saying it's normal with 160 and 10 square. Okay. And the same thing, I mean that of females, is normal distribution with 150 comma 5 square. Okay. The question is, a person, a random person is found to have a height of 155, let's say, centimeter. Okay. Then I mean we have to calculate the what is the probability that, let's say, what is the probability that person is male. Okay. So question is, uh, first of all, what are the things given?
Probability of male, female.
Male and female. So can I say X is the discrete, okay, which is taking male and female. For male, probability is 0.6, female is 0.4. Yes or no?
Yes, sir.
Yes.
Yes, sir.
Right. And we need to focus here. It is saying height of an adult male in that age group is normal. So you can see for male it is mentioned. So that means it is given that X is given as it is male. Then let's say height will be what? It's the normal 160 comma 10 square. Is
Yes.
it what?
Yes.
Yes. Yes, sir.
Are you able to relate, right? Now, if I'm saying, if you see, you can see, sorry, where it went. So you can see the next, it's the height of females, right? So that means it is given that X is female, then it will be normal 150 comma 5 is square. So far so good.
Yes, sir.
Yes.
Are you able to relate, right? Now question is,
Yeah, yeah.
if I will ask what is the probability of Fy of y, then how will you proceed?
So probability of normal distribution f given f of y given male into the probability of male and
But in
plus
numerator, we will
Px
find
of
the
x,
probability of
right?
male.
Px of x, y given x equal to x of y, yes or no?
Yes.
Yes, sir. And in denominator, we'll find the total probability.
Total probability, right? So this is something you can calculate, right? So it will be, basically it will be 0.6 into this probability, right? Fy given x equal to m and y plus 0.4 into Fy given x equal to f of y, yes or no?
Yes, sir.
yes, sir.
Correct? Now I'm not going to calculate the exact value because it will take some time. I'm just giving you idea. So main question is, what is the probability if a person, given that a person is found to have a height of 155 centimeter. So let me see, given that probability height is 155 centimeter, here y represents the height. What is the probability that person is a male? Right? This is something we have to calculate.
Yes, sir.
Yes.
So this means numerator part will be what? X equal to m and y equal to 155. Denominator will be fy of y. Basically, fy of 155 you can say, right?
Yes.
Later you can substitute the values of y, whatever the things you will get here. What will the numerator part here? This numerator part I can write as a
Point
px
six
of m.
into
I mean, what is the probability of being male? Fy given x equal to m at 155. Would you agree with me?
yes, yes, sir.
And we have to substitute the values. At the end, we will get the some final answer. Is this clear?
Yeah.
Right? Yes? No?
Yes, sir.
Yes,
Uh,
sir.
Yes, sir.
let me take one more example, then we can. So, uh, let me say, so let y is equal to x plus z, okay, where x follows uniform minus 3, minus 1, 1 and 3, okay. This is the case. And z follows, we have to think a bit normal 0 comma sigma square. And these two are independent actually, okay. So what is the distribution of, basically what is the distribution of y? Okay, you have to calculate distribution of y. So to calculate here you can see x, you have information about x, but you don't have about condition information about conditional distribution, right? So can I say y given x equal to minus 3, right? It will be what? Tell me.
Z plus minus 3.
Minus 3 plus z?
Yeah.
Yes or no?
Yes,
Because
sir.
y is defined as x plus z, right? So when
Yes.
x is minus 3, then y will be minus 3
And
plus z.
yeah.
This will be normal distribution again
Hmm.
with the mean. What will the expectation
3.
of this part?
Sir, minus 3, normal this minus 3 comma sigma square, sir.
Minus 3 comma sigma square, right?
Hmm.
Everyone is getting
Yes.
this? So if the expectation of z is 0, then expectation of minus 3 plus z equal to minus 3 plus expectation of z. This is again minus 3. Yes or no? And in case of variance, you can, adding a constant,
Agent
subtracting the
effective
agent
variance.
effect, right? Same we have to do y given x equal to minus 1. So it will be minus 1 plus
Z.
z. It will be normal minus 1
Minus
comma.
1 and sigma square.
What about y given x equal to 1?
Uh,
1 plus
Z
Z.
normal 1 comma sigma square.
1 comma.
Sigma square.
Y given x equal to 3.
1 3 plus Z
Z.
normal 3
Normal.
comma.
Normal
3
3
comma
cross.
Now
sigma
you
square.
have all the conditional and you have marginal distribution of x, right? So it will be, it
Hmm.
will take each values with probability 1 by 4.
4.
Right, so it will be summation of x throughout the range of x, px of x, fy given x equal to x, y.
Hmm.
So it will be basically what you have to do, basically px of minus 3,
4
fy
conditions.
given
Hmm.
x equal to minus 3 at y plus probability x equal to minus 1 into fy given x equal to minus 1 of y, then plus
Hmm.
px of 1, fy given x when x is 1, y plus px of 3 into fy given x equal to 3 and y. So you can see we have to just substitute the all the required values. Okay,
Yes, sir.
is the funda clear?
Funda clear, sir.
Okay,
Yes,
some
sir.
rough
Yes.
idea is okay.
Now just put, we have to put
We have
uh,
to just substitute the all the values. I mean, for x we have to substitute.
I think sir, I have done this question. This question is very familiar. Okay. I see.
It is in ZA or PA.
Yeah,
GR.
somewhere it's there, so you can see and try.
Sir,
Yes.
sir, one thing I am facing problem. From language, I can't find out where to use normal distribution when in language based question.
So it will be mentioned. It will be mentioned. You can see it's mentioned clearly. Height of adult male is follow normal.
Oh.
Okay.
In that, when normal is mentioned, I can find out.
No, most of the time it is mentioned. If you are talking about some standard distribution, right? Maximum time it will be mentioned. It's not like, see, sometimes let's say binomial Poisson and all. So binomial is something you can say this is something very obvious.
So sir, for quiz one, week 1 to 4, na?
Correct. Only week 1 to week 4. In that
Because
case,
in previous terms, until week 1 to 4 is covered before week quiz 1. But in this term, quiz 5.
It depends on terms, right? So in which term you have taken the admission. Okay, it depends. It's not. It is going to same for each term. Okay, it depends. It may vary. That's not case for each term. One more thing I would emphasize for quiz 1. So there is something theorems, right? In week 2, theorem, I mean that conditional probability of binomial Poisson and all, right?
Yeah.
So just do the preparation for that also. Okay, one more thing. Week 1 revision session of week 1 and 2 are done, right?
Done.
Okay. So any one of you have any other doubt related to week 1 and week 2, or is it okay for week 1 and 2? Some questions has been discussed also, right? From the previous quizzes?
Yes, discussed.
So you got the idea, or you need any other?
Idea is clear from
Okay.
those questions.
Okay. This is for everyone?
Yes, sir.
Okay.
Sir, I didn't attend that. Can anyone please
So you
send me?
you can watch the YouTube session, right? You just watch the YouTube recording. You can find out from the calendar itself, and do let us know. So since you have one more week, okay, that's why we kept week 1 and 2 revision session of week 1 and 2 earlier, so that see, we can divide the topics at least. So it shouldn't be we are revising everything at last moment. Okay. So we did for week 1 and 2. Just do the revision and just try to solve some more questions from week 1 and 2 without seeing the solution, and just check whether you are able to solve the questions or not. Then you will get the idea. Okay, so for week 1 and 2 we have to put no, you have to give more effort, and then once your week 1 and 2 will be clear, then there is another session for week 3 and week 4. That's all. It's done. And there will be mock. Just try to attempt mock without seeing the solution. Okay. Okay.
So mock solution is given.
I mean, without seeing solution. I mean, without seeing. Do not copy.
Without using ChatGPT.
Something. Yeah. Correct. So ChatGPT will help you to give to understand the concept, to give the idea, but it is not going to help you during the exams.
Yes, sir.
Okay. I think you got. Did you get something about from week 4 or something?
So week
Yes,
4.
no?
Until week 4, the topics are okay. Week 5 is much complicated, I think.
Yeah. I can understand. So it will be a bit. Then similarly for week 6 will be there, but yeah. Anyway.
Sir, would it be possible to share previous quizzes or exams question bank?
Question bank. I need to check.
You can go to S grade.
Yeah, there is something circulated among the student, right? I think. Can you share here? Is it possible?
Okay. Just search on Chrome S grade. ACGRAD.
Okay. Then is there anything else? Yeah. So you can find from the chat box. Okay.
Thank you, sir.
Yeah. Thanks all. Bye.
Sir, Wednesday you will take session.
There is 2 sessions, right? Tuesday and Wednesday. Yes, Wednesday I will be taking.
Okay.
Okay.
Thank you, sir.
Thank you. Bye.
Okay, bye.